Good morning. Um, Welcome again to this session where we are going to discuss about landslides. So we have just shared some videos of what landslides are all about, and landslides are not particularly fun. That's something which I'm sure that all of you agree, because it all happens so fast, and it doesn't feel like you are having actually a lot of time. So one of the things which also accompanies a landslide is the what you call as the boulders and other things which are falling. Now rock slides, when they happen, you can always imagine that it is going to be much more destructive than the land alone which is coming along. Now probably I will be sharing with you some of the what you call as the pictures of trucks, which I saw one particular landslide where a boulder rolls over the side and it crushes a truck totally. Now this kind of what you call as a situation is actually rather frightening. Okay. So let us probably see what are the effects of an landslide. Yes, Pramod.
Yes, sir. Yes, sir.
Yes. What are the effects of landslide?
If
Yes.
that destroying the humans' residence, sir.
Okay, destruction of habitat. Okay, after Pramod, Ravuru Uttam, Sai Vignesh, and Sanchit Garg. Ravuru Uttam, Sai Vignesh, Sanchit Garg. Okay, so destruction of homes, okay, or destruction of habitat, because it is not only the homes of humans which are getting affected. We are also finding that the animals, when trees are getting affected, birds. Okay, we also don't know how much of rare plant life, and sometimes other there are so many exotic creatures which could also get affected. We don't get to see them, so it doesn't mean that they don't exist.
Yes, sir. Good morning, sir.
Good morning.
Sir, lines of communication will black out, sir.
Very good. Lines of communication. Okay, when you say lines of communication, I'm going to do a little bit extension. By communication, we are also. Okay, you please mute yourself here now, please. It's too much of noise. Thank you. Right. By lines of communication, I don't only see the what you call as the normal telephone telegraph lines. If suppose electric poles are there, they can get uprooted. So this is causing a lot. This will cause a very cumulative effect. So then after that, nowadays like we many times depend also on satellite communication, but optic fiber and others such also get affected. So gas lines and roads, railways. See, for example, if a bridge is getting affected, then it is going to be very destructive. Okay, electric poles, gas, roads, railways, so on and so forth. These are all some bad things that happen. Going beyond, we are also seeing that you are going to have the so maybe here roads. I also will add bridges. Okay, roads, bridges. Typically, when a bridge gets destroyed, no vehicle can go. See, suppose it's just a road getting blocked, you may be able to take a bulldozer or something, clear the path, and then still somehow manage. But if suppose the bridge is damaged, it becomes even more tricky. Now moving further, we also will see that we are having a trouble with blockage of water bodies. Okay, so when you saw the videos, in some of the videos you'll see that the soil mass slips into the water, and then it blocks the entire thing. So this causes floods. Okay, because the water which is supposed to be inside the lake or if suppose it is a river which is flowing and the river path gets blocked, the water which was initially flowing comes to the land. If the water was supposed to be inside the lake, the equal volume of water which was displaced by the soil, Archimedes principle again, gets into the habitat. So flooding happens. Not a nice thing to do. When flooding happens, everything else, loss of habitat, you name it, it's all going to happen. And again, when you have this blockage of water, sometimes you also have tsunamis. Okay, that is because the land mass slips into the water at such a high rate, the water gets displaced very rapidly, and it forms a big what you may call as a wave, which we loosely call as tsunamis. So you will find that earthquakes are not at all, I'm sorry, landslides are not at all pleasant things to happen. Okay. Now, for example, in the previous class, we were seeing some of the reasons for landslides. Okay, we were seeing the reasons for landslides. Okay. Now, let us again just very quickly recollect. You will see that landslides because slope is unstable. Okay, landslides occur because of slope instability. Okay, when we stay unstable, it means that it is not in a state where any external disturbance can be taken up. So, I think in physics you have studied, okay, 3 states of equilibrium: unstable equilibrium, stable equilibrium, and then you have the okay, I am not getting this right. Let me just try it again. So, this is the funnel which you usually have as an example of the 3 states of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium. Okay. Now, when you talk about slope stability, if suppose the slope is not able to stay up, then we have a landslide. So, typically you have a mountain, the mountain likes to keep the slope at a particular level. So, the slope is determined by some parameters. What are the parameters? It is actually the type of soil. Okay. So, if suppose it is very grainy, it can interlock and then it can stay. Suppose it is a sticky type of soil like clay, because of the sticky nature itself, it's able to stay vertical. But the problem with that sticky nature clay is, sticky nature soil is, if suppose water is added, it becomes mush. Okay, it becomes like jelly, or even worse, it can even become like water. So, this means that the type of soil is something which is also of which is very important. Second thing, amount of moisture. Okay. So, as we are talking in the previous class, as we are discussing in the previous class, if suppose you take a soil mass, you add some water to it, you will find that it is able to take different configuration. Okay. Although not a very good example, all of you are familiar with atta. Most of your parents would have done puri, chapati or something of that sort. If you see the atta in the loose dry state, it takes a particular shape. However, when you add just the right amount of water, you will be able to make it into, roll it and even make it stand vertically like a pyramid. Okay. So, you can probably try this out at home. You can probably ask your mother to give you some chapati or atta or maida or something. Try to see, you will be able to visualize what I am saying. But on the other hand, you keep adding much more water, it will not be able to retain a different shape. So, moisture plays a very important role. One of the things it does is, it kind of pushes out the amount of air which is there, and it kind of increases the weight of the soil. So, actually what happens is, the soil stays at a particular slope because of friction. Okay. And if you remember your basic physics, please don't say this is civil engineering. Okay, this is all, I don't know which class you studied. Friction is a function of the weight. Okay. So, friction is always directly proportional to the weight. So, more the weight, automatically the friction is going to increase. So, when I am adding soil, soil displaces air, water is heavier than air, so automatically friction increases. So, the slope also can increase to a larger level. Okay. So, why do you say friction? Suppose you have very good friction, see, you will be, if suppose there is no friction, you will be able to only walk on level ground. Suppose you have little friction, you can keep increasing the slope. Okay. So, you can increase the slope till a particular level. In other words, depending on the friction on your shoes, between your shoes and the rock or whatever is there, or the sloping material, you can keep going up. This you would have studied, this you would have experienced in sliding board. Okay. I don't know how many of you ran up a sliding board, because it is more fun to do that than wait for your turn to go behind the ladder and come down. Okay. So, you will remember that when the slope of the sliding board becomes more, you have to really push against the sliding board. Okay, although you are holding it, it actually is, you are having a self-straining system which pushes against the sliding board, and then you are able to climb up. So, that is what happens here also. When the friction is more, what we call as the internal friction, the soil can stay up much more. Okay. But now we have a problem. The problem is, the soil is comfortable till it's not having any load. So when it has more load, I have to do two things. One, I have to think of going for a smaller slope so that the soil will still be able to take the load. Okay, when you look at all of this, it is essentially trying to keep the load within the soil mass. So I'm not going to go too deeply into that. Okay, but the main thing is that you will have to either increase the slope, or I can do something here. I can put some cement or something, making this soil able to take more load. Okay, this is why we use the example of the beach. What you do, you add a little water, you try to make the sand castle stay up. Okay, the moment moisture is lost, the sand castle will crumble and fall. So you try to make the soil just to the right amount of moisture. Can you very quickly summarize what are the things which determine the stability of a slope? In other words, when soil is heaped up, what are the things that are required to be observed when you are going to look at ensuring that it is stable? You don't want
First
slides.
is the type of soil that it is
Okay.
sticky or it is clay type of soil or almost sandy,
Yes.
depending upon the type of soil.
Ah,
Next is the moisture condition, sir.
very good.
Like, and third one is the friction,
Excellent.
and the fourth one is weight due to its own weight of the soil.
Okay.
And
Or-
next is the overburden.
Yes, overburden is what is the extra load which you are giving. Thank you. Okay, Daphne, are you around, please? Okay, Daphne, can you just explain what internal friction is, please?
It's the ability of the soil to withstand shear stress.
Withstand shear stress. Okay, now there's a new word. What is shear stress? Sliding forces are shear stresses. Basically, sliding stresses are shear stresses. Okay, now let us take this what you call as a skateboard. Okay, this force, what is happening downward towards gravity, is called a normal force, or what is the action due to gravity. And shear force is the force which can come under sideways. So typically, you know, like all of you have done the parallelogram law of forces in physics at some point of time or the other. So now let us, the soil could probably be standing at this way. So you will find that, you know, you can always split the forces into two, one towards gravity, two on the other side. So what Daphne was talking about, shear force is this force, and this is called as the normal force. Okay, normal force is the downward force and shear force is the sideways force. This is probably the only two civil engineering terms which I am using, and again I am only using it on parallelogram law of forces. So please don't think that we are doing something very fancy. Nothing fancy is being done over here. Okay, so friends, it is very simple. To make the soil stable, we have only to do these things. Sometimes this will not work. Why will it not work? It is because I want to construct a, let us say, let's take a random person, Gautam. Hey Gautam, can you unmute yourself please and say good morning to everybody?
Good morning, sir.
Good morning Gautam. Good morning to everybody, yaar, not only to me.
Good morning, all.
Yeah, thank you Gautam. Gautam, now suppose there is a mountain, what are the types of what do you call as man's intervention that happens there? What are the things man does in a mountain?
Plantation, sir.
Plantation, okay.
Like you mean effects or like
Let us say that, you know, you are going to do some construction, you are engaging a civil engineer to do some work. What are the things you are going to do?
maybe like a staying spot for mountain climbers.
Excellent. Let's say that's a holiday resort. Okay, so my mountain is like this. Okay, and Gautam has asked me to construct a resort. So what would be done? I will take the mountain and make a nice cut, right? I will take a mountain, make a nice cut. Time, yes. So I am taking away the mountain, and now the mountain looks like this. Now what I can do the resort. Okay, So I do the resort. It's a lovely place. You see the birds, you see the sunrise, sunset, whatever, and it's a nice thing. Is this something you would have liked, Gautam? Something bigger?
Not exactly at that spot.
Where would you like it?
Like
More to the top, more to the bottom?
it depends on topology, no, sir, like the land condition.
You forget about that. Okay, as of now, we are only trying to see what we can do to get this done. Okay, so now if you see, is this, I mean, you just take it for example that it's a small, nice cottage in the mountains. Okay, so what happens? This soil which was initially like this has been broken. So what you have to do, either you have to make the soil very strong, or you have to do some intervention. You have to make a retaining wall. Okay, so you have to make a retaining structure. Sometimes you will also have to strengthen the base. Somewhere here also you will have to do. Sometimes you will do what is called as earth stabilization. See, you can do any one, you can do all of them, you can do like you can it depends on how you work it out. Okay, so you can do some earth stabilization. Alright, so this means that we will be injecting some chemicals, or we will be injecting something like lime. Lime is again a chemical, or we will do something called grouting, where we fix all the smaller places with some cementitious material, something like cement, so that makes it strong. So you can do some earth stabilization, and also you can do so these are the principal things which you do. The other very important thing is you should know what is the weight of this structure. Suppose there is one more resort over here on top, weight of this resort also, because this resort weight was transmitted to this part of the mountain. Now this load is actually being transmitted through this retaining wall. So these are some of the designs which you probably will be doing. Okay, so with this principle in mind, let us see some of the ways by which you can do the what you call as the what you can do as the stabilization techniques. Okay, so you can go for what are called as Gabion walls. Okay, so you would have seen this also in at various occasions, I presume. But in any case, let me just probably try to get you a what you call as a picture of the Gabion wall. So let me just probably bring it out from Google itself straight to you. These are examples of Gabion walls. Okay, if you see, it is nothing but sand which is put into, small rocks which are put into a mesh. Okay, it's a wire basket. If you look at this one, you will be able to hopefully see it better. So here you see this is a wire basket inside which we arrange stones in a particular pattern, and believe me, this is very, very strong. This is very, very strong. It is not going to fall down just like that. The other thing is you can also do some seeding. Okay, so you can make plants grow. Yeah, here it is. Okay, so here is a way by which you can also induce some plants. So they will deliberately put some seeds in it, and then they will do some construction. Okay, so you will find that there are a lot of resources which are available for you. Just to you can just go through it, and you will find that it is very, very it should be very interesting for you to learn. Okay, other things which you can do, like there can be what we call as depending on the load, you can have what are called as sheet piles, or you can construct a pakka retaining wall. Okay, or there are other techniques where you spray concrete on the surface of the slope and then you make it stable. So these are all some of the ways by which you can probably stabilize the structure, and we have seen this done in different places also. Now there is what are the things which you can actually see which could be what you call as causing this disruption, or what can cause landslide. Okay, so what can cause landslide? See, human intervention is one. Okay, but then if suppose the grain is soil particle distribution is disturbed, okay, for example, this can be done by very easily by earthquakes. Okay, earthquakes cause vibration, and when it vibrates, the soil takes a new shape. You can see this in your kitchen. Again, go to your mother, watch how she makes chapatis. Typically, they'll take the atta and it will be looking like a mountain. It will be atta on a let us say atta is whatever color. So you will find that the atta is initially heaped, okay, and usually the measuring cup will be kept on the top. So the moment the measuring cup is kept on the top, you will notice that the atta takes a slightly different shape. Now what happens? Usually it is taken and put on a sieve. It is put on a sieve and then you shake it. When you shake it, you will find that this what you call as the pyramid slowly starts to take the shape of the pan itself. Do you agree with me? Okay, if anyone disagrees with me, you can, okay, those of you who agree with me, raise your hands. I think I'll put it that way. Let's see if anybody is disagreeing. So what we are saying that when the atta is disturbed, okay, the atta takes the shape of the pan. So if you agree with me, put your hands up. So what do you think will happen when you keep atta and shake it?
Sorry, sir.
When you take atta in a sieve and then you gently shake it to the left and right, what will happen?
It will slide down.
It will slide down, okay. So I am saying that it will become level and it will take the shape of the container, okay. You are saying no, okay. I think you are right. Can you just explain the reason for your answer?
Due to vibration, all particles will fall down and
Yeah, I know. This was a very big trick question because when you shake the sieve, most likely all the atta will fall down. Okay. See, guys, this is an example of an ambiguous question. Okay. See, in many of the times, we faculty members make this mistake of asking ambiguous questions, and you are always welcome to tell it in my class, sir, what you are saying is nonsense. Okay. So you don't hesitate to what we call as point it out that I am wrong. Okay, thank you so much. Thank you so much, because this was the thing which I was trying to find out from you, like see how people react. So maybe if you put it in a plate and shake it, it's going to take the shape of the plate, and if it's a sieve, it is expected to go down. Okay, friends, please don't think I'm being silly, but yeah, this is something where we actually make mistakes in asking questions. So let me move on quickly. So this is something which happens when earthquakes are formed, when there is an explosion. So for example, when you're having a Diwali tamasha, you'll be able to understand how when certain crackers are exploded, your entire house seems to vibrate for various reasons, because the excitation frequency might be such a, like the structure could be undergoing free vibration because of the nature of the impact, and when that happens, it also goes into the soil. Again, even the explosion itself can cause what you call as the soil mass to start to vibrate. So again, if you see, if suppose you want to level the surface, you'll be taking a stick and like with a heavy weight like a hammer, and then you pound the soil becomes more level. So this is one of the things. Then the other very important thing is very dangerous thing is also vibration. Vibration can be due to your earth compacting machines which have vibrators built into it, or your bus, your car, even your cycle, okay, can cause sufficient vibration for soil to reshape itself. Okay, so these particle disturbances can cause the soil to reform. The other very important thing is it can cause liquids to move. It can cause liquids to move. In particular, when we are talking about soil, I am only talking about water. Okay. Now, when this water is disturbed, it moves from bottom to, it moves through the layers. It gets squeezed because the soil is trying to come close to each other. The water gets squeezed and then it moves. When it moves, it does a lot of things. The weight of the soil, you know, like, you know, Archimedes principle also comes in here. So because of buoyancy, it kind of, you know, starts to make the soil lose weight sometimes, and also the net effect which it has is totally different. It's very difficult to kind of, you know, go through the entire gambit of soil mechanics, but one thing you can be sure, when liquid moves, it's not a good thing. Okay, so you will find that liquefaction of soil takes place. In particular, I am going to direct you to one of my previous videos where we are having some videos and other things, and the main reason why I prefer not to use videos in this class is when there is a lot of videos, you know, like it means that the experience which you have will not be the same as watching it on YouTube. So this is one more very important thing which happens when soil gets disturbed. It starts to move through, and when it moves through, it can make the surface of the soil turn to jelly, and whatever is on top can start to sink. Okay, so these are some of the other causes of landslides, like some disturbance, some vibration, it may be even earthquake. Okay, so you will you can protect yourself by engineering a solution, okay, by using retaining structures. Okay, there are many types of retaining structures, but I am not going in for all of them. But one thing you need to know, that if suppose you are going to have what we call as the retaining structure, things are going to be fine. Okay, so you will yeah,
Excuse me, sir.
yes please.
Sir,
tell me.
this avalanche and this landsliding, same thing.
Actually, avalanche happens in snow. Usually
Yeah,
what happens, a
but
small
the logic
disturbance.
behind it, sir.
Frankly, I will not agree, because an avalanche is caused by, you know, you can take a small stone, it will start to roll and keep on what you call as getting larger in size, causing more disturbance, and then it causes a massive movement of the snow. Here the movement of soil is different, the way it behaves is slightly different. Okay, avalanche also is because of a small disturbance, but soil movement is what we call as, you know, little more complex. So more snow can make a higher slope, it can make it unstable and then make it flow. But when I am talking about landslides in particular, the soil's internal cohesion or internal friction. Okay, cohesion and friction are two different terms. Between to make a soil slope stable, it can be a combination of friction plus cohesion. So it makes it a little more complicated to visualize, or, you know, to visualize a solution for this one, what you call as the landslides. Okay, I hope I'm able to make sense to you. Right, friends, in all of this whatever I have spoken, I'm only asking you to visualize with things which you have already seen. Atta in the kitchen, how much water is there, how it makes the soil stay up or stay down. So when you go for your construction, please ensure that your retaining walls are there. Okay, so it doesn't mean that you cannot construct here. You cannot, if you see, many of the mountain roads are also like this. So if suppose it's rock, there is no problem, they simply cut the rock and then you go through. Typically you will see this near tunnels, there will be rock which has been cut, so it is able to stay up by itself. However, when there is soil, you will find that things like gabion walls, maybe sheet piles, maybe retaining walls are all done. Now if you go through your subway, you will see the retaining walls. In particular, I'd like you to have a look at the walls. They have what are called as weep holes. Okay, usually there will be some rectangular slits or some circular slits which are there. These are done so that when it will be something like this, the pipe will go through like this. Okay, when you see it, it will be something like this. This is done, this weep hole, this is called as a weep hole. Okay, this is called as a weep hole, and this is the section of the wall. This is the section of the wall. So when you look at the wall, it will either be a circle or a rectangle or square or whatever cut. So it will run through, and usually what we will do is we will put some boulders here, some sand and other things. So this is called as a filter media. Okay, now what happens when rain comes and water is flowing, the soil is prevented from flowing through this what you call as the weep hole because of the filter media. Sand allows water to pass through, and then there are some pebbles, and then there are some bigger stones. So this will allow the water to pass through, but it will not allow the soil to flow through. The retained soil will not be allowed to flow through. Okay. So now what is the reason? We don't want water to be accumulated, okay, behind the retaining wall. This retaining wall is designed to retain only earth, not water. So what happens when water comes? It starts to do a lot of funny things, okay, including something called hydrostatic pressure. Okay, this may be familiar for the students who have done fluid mechanics. I think electrical, mechanical and civil engineering students would have done fluid mechanics. You would have also done this in your what you call as your school level, but I am not going to go in for that. So basically the lateral force on the wall increases when water is there. So automatically, you know, like you need to have these weep holes to allow the water to go through. So why do you think my statement is there that when water is there, the pressure increases? See, when you are pouring water into a glass, okay, it has to rest fully on the side of the wall. However, if I am going to take what you call as soil in a similar glass and then I heap it, okay, now this part will push against the glass, okay, this part will push against the glass, but this part is more or less stable. Okay. So although the height is almost the same, the amount of lateral support which is required for these two different materials is totally different. Okay. So we have gone through some principles of landslides. I sincerely hope that you were able to visualize and, you know, relate it to some of the good things we did. So it is again that, you know, I am relating it to the sliding board. So if you are having a very steep slide, you need lot of friction to be able to climb up. That's the same thing which happens here. If the soil has lot of internal friction, you will be able to take up a very steep slope. If not, it has to keep on reducing. If the overburden increases, so just like how we were talking about the atta, the moment you keep this cup, the atta is going to slide down. So you need to do something different. Okay. And again, this is shaking, you know, when you shake the atta, it tries to reshape itself, it needs some lateral support. So that's what happens. So when vibrations and other things are there, you need to provide some lateral support for the soil, and all of this can be engineered. Okay, when you don't keep this, then you are in trouble. Okay. So civil engineering students, can we give an assurance to all our other friends that, you know, we guys know what to do? Yes, no? Civil engineers, you could probably raise your hands.